we just added the ability to update transactions with new outputs and reassigned input for a sender who has already created a transaction. Let's test that new functionality by encapsulating a few tests within the transaction test file with a describe block that covers a situation where we're updating a transaction. So right at the end, let's make a new scenario with a describe block. And in this situation, we're going to be updating a transaction. We have our callback arrow function as the second parameter. The test within here will have a similar structure to our transaction test overall. Each transaction in the above unit tests had an amount and a recipient. Likewise, for these tests, let's declare a next amount and next recipient variable that we can use within the tests. Then, before each of the following tests within a before each block, we're going to assign these values. So let's add a before each block. The one parameter is an arrow function. And then let's set these amounts to something arbitrary, like the next amount can be 20. And then the next recipient, how about the least speak version of next address, so N3XT-4DDR355, and notice that looks something like next address if you were to force yourself to read those numbers as letters. And now we can update the transaction variable to an updated transaction that uses the wallet, and then these next variables as inputs. So we're going to reassign the transaction to the result of calling transaction.update, and then we'll input the wallet, and then the next recipient is the new recipient, and then the amount that we're transacting with is the next amount variable that we just assigned within the before each block. All right, that covers creating an updated transaction for every following test in this block. First up, we want to make sure for our first test that the sender's output now subtracts the next amount as it calculates its final amount to have for the sender. So let's have a test which checks whether the next amount is also subtracted. So this test will say it subtracts the next amount from the sender's output. And notice that we can't use a single quote string anymore because of the possessive senders over here that uses an apostrophe. So let's fix this by using backticks for the actual message string, which will allow us to use an inner single quote within the sender's part over here. Then we'll have our callback function. And over here, in the actual test, let's check the amount in the sender's output. So we'll find the sender's output by looking for the transaction outputs, or rather looking through the transaction outputs, in finding the output whose output.address is equal to the wallet.public key. So again, we're going to look through the transaction outputs and then find the sender's output by using the find function, looking at one output object at a time through the transaction outputs, and then returning the one whose address matches the wallet public key. And then we'll expect that the amount in this output object is equal to the original wallet's balance minus the original amount that we transacted above, and also minus the next amount that we transacted with the update. So we'll access the amount variable within this output that we found, and then we'll expect that to equal the wallet.balance minus the original amount that we sent away within the first transaction way above over here. So it should already have subtracted the amount within this transaction. And now that the transaction is updated, it should also subtract the next amount it creates with this transaction update. Cool. Likewise, in a transaction update, it should create a new output for the new recipient. So we're going to have a new test that checks it outputs an amount for the next recipient. And then we'll have our callback function as usual. In this case, we'll expect that the output whose address matches the next recipient has an amount which matches the next amount. So again, we're going through the transaction outputs. We're going to look through the output objects one at a time, and then we'll return the one whose output.address is equal to the next recipient variable. We'll look at this amount, and then we'll expect it to equal the next amount that we specified to send to this recipient through the update transaction function. All right, great. So make sure you have both of these tests. And with that, we wrap up testing the update feature. So let's run the actual test script in our command line and check if these new tests pass. So go ahead and open up your command line and then run the test runner, which is npm run test. And as we do so, we're going to hope for passing tests. And indeed, all the tests pass, showing that the update feature works just as expected. Excellent. With that, we have a pretty powerful transaction object within our blockchain-based system now. Let's start handling transactions submitted by multiple users next within the network. We'll explore concepts such as the transaction pool, which is a shared object that collects the transactions submitted by every user. We'll also explore the question of how to actually use transactions as the data for blocks within the actual blockchain. All right, let's get to it.